Okay, so what are we doing? What's the problem? The enthalpy of formation of ethanol, no, that's not right. Calculate the enthalpy change for the reaction. I want to do the enthalpy change of the reaction. Notice that's a balanced equation, yes? That's for the combustion of 1 mole of, what's that chemical called? Yes, you have to know organic eventually. I'll give you a hint. Methane is 1 carbon. Ethane is 2 carbons. Butane is 4 carbons.
Propane.
Propane. Yes, you cook with it, barbecues, etc. Okay, so now it's simply this. This is the equation. It's kind of brain dead. Anytime you do enthalpy or entropy or Gibbs free energy, it's going to be the sum of the products here. What's an element considered? Heat of formation of an element is considered. You have an element. There's 1 element here. That's an element. What's that considered?
A mole?
It's 5 moles actually, but it's considered what?
A molecule?
What's the heat of formation of an element called? 0. Yeah, it's considered 0, right? All right, so that's why you don't have it. It's a little greater than 0, but it's considered 0. Okay, so we have what are the enthalpies of formation? What is it? It's right in your book there. What is it of propane? And these are all per mole now, don't forget. Anytime you get one of these values, and they're all in your sheets, it's per mole. What is it for propane? Negative what?
105.
Negative 105?
Yeah.
Kilojoules per mole?
Yep.
Okay, do I have to put that?
No.
Okay, these are going to be kilojoules per mole, right? 105. See, it's negative, right? What's oxygen?
It doesn't say.
Oxygen's considered 0.
Oh,
We
yeah.
just said it. That's all right. Monday is difficult for re-entry, any time of the day on Monday. What about carbon dioxide?
Negative 395.
Negative 391. Okay, now remember, these are all gases. That's also very important. It's a gas, it's a gas, it's a gas, it's a gas. Okay, and this is going to be what? 391?
394.
394?
Yeah. Negative.
Negative 394. Okay, very stable, huh? Very stable. And what about water?
Negative 286.
Negative 286.
Is that stable?
Water's pretty stable, yeah. I would say water's pretty stable.
What if like can you tell the stability of an element by like a certain number? If it's like below negative 100 or something, it's quite stable.
Can you know the stability of a substance by looking solely at its enthalpy of formation? Possibly. You have to look at a few more sources, a few more things. But yeah, you get a rough idea of its stability. Okay? Because the more energy it gives off, the more energy you're going to have to put in. Okay?
So positive enthalpy is unstable?
It's not necessarily unstable, but because there are other factors that might go into its formation, such as changes in entropy. But I'm simply saying to you is it could be, Eden, it could be. Difficult to work in absolutes relative to thermodynamics. But yeah, it could be. It could give an indication of stability. All right, so I want to know the total product. So what's the total products? I need to add it all up, guys. You got to add it up. This is simply accounting. So what's 3 times negative 394? Give me the whole thing. Just give me 3 times 394. What do you got?
Negative 1182.
Negative 11,
82.
negative 1182. Okay. And you're going to add that to, give me 4 times 286.
Negative 1144.
Negative 1,
1
4,4. Okay? Yes? Okay? And now add those two values together. They're both negative. What do you got together? The sum. 11, 82, so 22, 23,
Negative 2, 3, 2, 6.
negative 2, 3,
2, 6.
2, 6. Okay? Now, I want to add that to the only one here, and it's only 1 mole, right? Negative 105. Right? So that's going to be plus, wait a second, minus, right? Sorry, did I do something wrong here?
Yeah.
Yeah, they didn't say minus, I did. Right? Minus, I thought they made a mistake. Minus negative 105. So what's the value going to be?
Negative 2, 2, 2, 1.
Negative 2, 2, 2, 1. Right? So could you go out on a limb here, Eden, and say that that is going to be more stable? That the products are more stable than the reactants? Yeah, absolutely. So, yeah, so then you could say that, well, the 105 was not very stable, was it?
But the rest were stable.
Yeah, like these were very stable, these are not stable, so you could pretty much say that it's gonna do it, right? So, the way you really find out, and we're kind of getting into the realm of Gibbs free energy, where you're gonna be able to predict, using thermodynamic quantities, whether or not an equation will run. Pretty cool, huh? You're gonna be able to predict. You're gonna know. You're gonna know. Pretty cool. Is there anybody who has a problem with that? Lauren, what do you think?
I think your batteries.
In the,
My battery's running down? All right, kind of like me. I'm 60, so my battery's running down too. I wish I could put it on a recharger. Something other than caffeine. Yes?
in this one, is it just the reactants and the products in the different bars, or like?
All right, just give me a second here, guys. All right, can we deal with that question right now? But not, I'm just gonna turn this off, okay?
Yeah,
Are we okay with this? We're cool? Portium? Okay? You know what they call Portium
A genius?
out on the street?
A genius?
No, they simply call her Miss Chemistry. You know, that's her like nickname, you know what I mean? Okay, Miss Chemistry.